Good morning, ma'am and classmates. I am Eliza Marcelino and I'm going to report the lesson 6.3 about colligative properties of non-electrolyte solutions, the freezing point depression. So, let's start. In this page, let's learn about freezing point and freezing point depression. Let's find out their meaning. First, the temperature at which the vapor pressure of a liquid is at equilibrium to the vapor of its corresponding solid state. And while the freezing point depression is another type of colligative property where it is only dependent on the concentration of the solute particles present in the solution. For example, when a solute is dissolved in a solvent, we can observe a decrease in the freezing point of the solvent in the solution. We refer to this situation as freezing point depression. So next is, how does the depression in freezing point occur? Let's find out more about freezing point depression. So, it happens when a solute is added to the pure solvent that results in the lowering of the freezing point of the solvent. Because when a pure solvent freezes, its particles move slower and become more ordered as the intermolecular forces that operate between the molecules become stable. For water molecules, the hydrogen bonds create a hexagonally shaped network of molecules that result in the structure of ice. By adding a solute into the liquid solvent, this ordering process is disrupted. One example is when salt is added to water. Because it's harder to form ice, since Na plus and Cl ions tend to attract the water molecules. In making ice, the solution must be cooled to a lower temperature. So, remember that the difference between the freezing point of the pure solvent and its solution is called depression in freezing point. So, the freezing point depression is also related to vapor pressure. Vapor pressure of both solid and liquid states must be equal at the freezing point to reach equilibrium. And according to Raoult's law, an addition of a solute to a solvent leads to a decrease in vapor pressure. Therefore, lowering the vapor pressure results in the lowering of the temperature, at which the vapor pressures of the liquid and solid states of the solution will be equal. So our next is, welcome to calculating freezing point depression. Remember that the difference between the freezing points of a solution and pure solvent can be written as delta Tf equals to Tf minus Ti, like this. And here's the detailed naming of them, where Tf is the freezing point of the solution and Ti is the freezing point of pure solvent. We can see here the phase diagram of solution solvent indicating the freezing point depression. Just like in boiling point elevation, the change in freezing points between pure solvent and a solution is directly proportional to the molar concentration of the solute particles. So next is that the negative sign in the last two expressions in equation 6.3.2 is the result of positive Kf because delta T is negative while the concentration is positive. In some textbooks, Kf is already a negative value. If this is the case, the negative sign should not be used anymore. So always remember that the freezing point of the solution is always lower than the pure solvent. Here's another formula we will use that written as delta Tf equals to negative Kfm, like this. And here's the detailed naming of them, where Tf is the freezing point depression here, while Kf is the freezing point depression constant here, and M is the molality of the solution here. Synonymous with the boiling point elevation, the freezing point depression constants are also properties that depend on the identity of the solvent. So, the values for Kf for some solvent are listed in here in table 6.3.2. You can pause the video and study this table so you can learn more. Don't forget and remember that the freezing point depression is directly proportional to vapor pressure. When a solute is added to a solvent, the freezing point of the solution also decreases. So next, let's practice some examples. Example 1. Let's calculate the freezing point of an aqueous solution where enough lactic acid or CHO is added to make 0.25 molal solution. The K for water is 1.86 degrees Celsius over M. First step is identify the given. And the given is Kf of water is equals to 1.86 degrees Celsius over M and M is equals to 0.25. Step 2. Identify what is asked in the problem. And the problem asked to solve for the freezing point of an aqueous solution. Step 3. Write the working equation. And our equation is this. And it's read as delta Tf is equals to negative Kfm. Or just look at the picture, this, so you can understand more clearly. Let's proceed to step 4. Substitute the values and solve for the new freezing point of water. So we need to write first the delta Tf equals to negative Kfm and then substitute the given numbers like Kf is equals to 1.86 degrees Celsius over M and molal solution this is equals to 0.25 M. So here's the detailed info. Where did I get them? Here. This is here. Step 5. Find the answer. So the answer is delta Tf is equals to negative 0.465 degrees Celsius. Nakuha natin ito by multiplying them and putting the unit in the final answer. This, multiply them first and then put. So, the new freezing point of water is negative 0.465 degrees Celsius since the freezing point of pure water is 0 degrees Celsius. Let's jump to example number 2. What is the freezing point elevation when 120 grams of lactic acid or CHO is dissolved in 600 grams of cyclohexane or CH12. Note that the freezing point of cyclohexane is 6.55 degrees Celsius and its freezing point depression constant is 20.1 degrees Celsius over M. Let's identify the given. The given are these four, this, and step 2. Let's identify what is asked in the problem. The problem asks to find the freezing point depression. Step 3. Write the working equation. And it is read as delta Tf equals to negative Kfm. Or just look at this picture so you can understand more clearly. Let's proceed to step 4. Substitute the values. First, solve for the molality of the solution. And you need to identify the molecular weight of lactic acid, which is 162.14 gram per mole. Because, gagamitin natin ito sa ating pagsusolve just like this. First, i-divide nyo sila ng sunod-sunod, and when you get the final answer, turn the answer into 4 significant numbers. And then, don't forget to put the units. And then, when you get that, multiply them. So, for you can fully understand, here is the detailed info I made, and it is also a guide for you where I got the numbers I use in solving the equation. So in this page, we have step 5. Let's find the answer. So 20.1 times 1.2335 is equals to 24.79335. Round it off the final answer if needed, and don't forget to put the units, which is degrees Celsius. So therefore, the new freezing point of the solution would be 6.55 degrees Celsius minus 24.8 degrees Celsius is equal to negative 18.24 degrees Celsius. So, that's the end of our calculation. We have only 2 examples, so here's the key points. Pause it if you are interested to read it. Then, here is our key formula. Pause the video and study the content. That's all. Thank you for listening. Again, I am reporter Eliza S. Marcelino from STEM 12, St. Sergius. Bye!